Okay, this is Algebra 2, Lesson 31. This lesson, we're going to talk about reciprocals and perpendicular lines and remote interior angles. So, we said 2/5 is a reciprocal of 5/2. Yes? And 5/2 is a reciprocal of 2/5. We also said negative 1/4 is a reciprocal of -4. So when we do the reciprocal, we don't change the signs. We keep the signs the same. We just simply flip the number. Just like 1/3 is a reciprocal of 3, or 3 is a reciprocal of 1, and negative 1/3, the reciprocal is -3. We keep the sign. We don't change the sign. We simply flip the numbers, the numerators and the denominators. However, if we say the negative reciprocal, so let's look at some numbers. So if we do negative 2/5, we said the negative reciprocal, so we're going to do the reciprocal. And what's the negative? It's the opposite of a number, so it goes from negative to positive. So the negative reciprocal of negative 2/5 is 5/2. The negative reciprocal of 5/2 is negative 2/5. Just like the negative reciprocal of 1/4 is positive 4/1. So first we do the reciprocal, and then we take the negative of this number. So it's negative, the opposite is positive. Just like, what's the negative reciprocal of 3? Well, we got to do the reciprocal first, and then what's the negative of positive 3? Negative. What's the negative reciprocal of 1/3? -3, or -3. Okay, so that's all reciprocals are. If you're just doing the reciprocal, you keep the sign. You don't change it. So the reciprocal of negative 2/5 is -5/2. That's the reciprocal of negative 2/5. The negative reciprocal of negative 2/5 is positive 5/2. So you flip it and you change the sign. Negative to positive, positive to negative, negative to positive, positive to negative, positive to negative, and then you also flip it. That's all reciprocals are, and negative reciprocals. Now we're talking about perpendicular lines. If we're graphing two equations, let's look at let's look at these two equations. Y equals -1/2 x plus 2, and y equals -1/2 x minus 3. These equations are well, they look like they're kind of the same, but they're not. They have the same slopes, and the slopes are both -1/2, but they have the different y-intercepts. One's at a +2, one's at a -3. So if you flip the page, and they've graphed them for us. I'm not going to graph it on here, but you can look at, it's at 31 point B. If you look at the graph on the left, they've graph these two equations, and I'm not going to graph, I'm just going to kind of show you. Excuse me, they look like this, and they are what? These two lines are what? They're parallel. They're parallel. The only difference is the y-intercept is where they start at the y. So, we can say that equations with the same slope and different y-intercept are parallel lines. Okay? Now, let's look at the example on the right. They gave you the equation y equals -1/2 x minus 3, and y equals 2x plus 1. Well, what do we know about -1/2 and 2? We just got through learning. 2 is the negative reciprocal of 1/2, because, right, the reciprocal of 1/2 is 2, and what's the opposite, or the negative of -1/2? It's positive. So these two equations have negative reciprocals of each other. And they graph them for us. When you look at the graph, the two lines are actually perpendicular. Perpendicular, we know, makes a right angle. So when you have negative reciprocals of each other on two lines, if the slopes are negative reciprocals of each other, then the two lines are going to be perpendicular to each other and form a right angle. So now we learned how to write equations with parallel lines. We said parallel lines have the same slopes. So we say write an equation, example 31.1 says write the equation that is perpendicular to y equals 2/5 x minus 3 and passes through the point 3, 2. So to write an equation, you need to have this format. So you need an M and you need a B. M stands for slope, in case you forgot, and B is the y-intercept. And y-intercept is where the equation crosses the y-axis. This is the y-axis and this is the x-axis. Okay? So, well, we know that the equation line we're writing to is perpendicular to this, and it passes through those two lines. Well, what do we know about perpendicular lines? We just got through learning that their slopes are negative reciprocal. So if the equation we're writing is perpendicular to this, here's a slope, it's 2/5. So what's the negative reciprocal of 2/5? I mean positive 2/5. It's a negative 5/2. So what's the slope? M. Negative 5/2. Now I need a B. Well, can I find it? Well, I know that this equation goes through those two lines, so I can substitute, isn't this x and y, and say 2 equals, what's my slope, because I found out my slope, negative 5/2 times x, which is 3, plus b. So I get 2 equals negative 15/2 plus b. So I'm going to add 15/2 to both sides. Right, and I can change this to do 4/2. So I get 19/2 equals b. So my y-intercept, my b is 19/2. And I can write the equation out. I've got y equals, what is my slope? Negative 5/2 x. This is plus 19/2. And there's your equation. And you can leave it in that format. So that's all you need to know. So perpendicular lines have negative reciprocals, and we just learned what negative reciprocal is. Now let's move on to remote or interior angles. So we have similar triangles. Pretend like mine are similar. I know, I'm not the best drawer, messy here. Okay? A polygon has one interior angle at each vertex and has two exterior angles. Okay? So let's look at these triangles. So A, B, C, A, B, C. Alright? Okay, so an exterior angle is formed by extending one side of the polygon. The triangle shown on the left has three interior angles, A, B, C. So now I'm going to extend this line and this line to get angle E. Okay? We know that these two angles are opposite because they're vertical angles. Vertical angles mean across from each other, and we learned earlier that those angles are equal. Okay? The exterior angles are equal angles that have equal measures. Okay? We can prove that the measure of each of these exterior angles equals A plus B. We're going to prove that this angle equals A plus B. What do we know about a triangle? This plus this is 180. So we're going to prove it. We're going to say A plus B plus C equals 180 degrees. Okay? And we also know that C and E make a straight line. And we know C plus E equals 180. Yes? Because of that, we can say A plus B plus C is equal to C plus E. And if we subtract C from both sides, we get A plus B equals E. So we just proved that these two angles equal that. And these two angles are called remote. Okay, A and B are on the other side of the triangle from the angle labeled E. These interior angles are called remote interior angles. Okay, so we just proved it. And we can say, when we get A plus B equal E, they use the QED, which you don't really have to know, but basically what QED stands for is the Latin words quod erat demonstrandum, which means that which has to have been demonstrated. Okay, that's it for lesson 31. So your practice problem and the code for this lesson is the number 500 on the top of lesson 29. 500 on the top of lesson 29.